Last question, number 5. Scanning machine. A machine is scanning for errors. On a production line, it finds errors at a rate of 13 per minute. 15-second period was the expected number of errors. What is the probability that 2 or fewer errors come in 15 seconds? And what is the probability that 2 consecutive errors are less than 6 seconds apart? So these are Poisson exponential interarrival time type questions. So this is really like a Poisson with a lambda of 13 errors per minute. So my lambda number is equal to 13 errors per minute. Okay. So the first question, in a 15-second period, what is the expected number of errors? Well, all of these questions down here are in seconds, but my lambda is in terms of minutes. So I have to convert everything to minutes, or convert my rate into seconds, I guess. But I'm going to convert all these seconds into minutes. So 15 seconds, that's a quarter of a minute. In a quarter of a minute, we're expecting to get a quarter of our per minute rate. So 13 divided by 4, that's 3.25. Okay, so problem number A, you get 13 divided by 4 is 3.25. And the reason it's 13 divided by 4 is because 15 seconds is a quarter of a minute. So 13 per minute, how many do you get in a quarter of a minute? You get a quarter of 13. Next part. What is the probability of 2 or fewer errors in 15 seconds? So in a 15-second period, we don't know how many we're going to get. Presumably, like 3.25 is the expected number, but it's random how many are going to come in 15 seconds. That is a Poisson setup. If you have a certain amount of time and you don't know how many hits you're going to get, that is a Poisson distribution question. So let's plug everything into a Poisson distribution probability formula. So the probability that we get 2 errors in a minute or in 15 seconds, well, the expected value for 15 seconds is 3.25. We need to do e to the power of that. E to the power of negative 3.25. Okay, because that's 13 times a quarter of a minute is 3.25. And then there's 3.25 to the power of the number we're looking for, which is 2. And then divide that by 2 factorial. And then that's going to give us the probability that we get 2 errors in 15 seconds. So I did this earlier. Where's my answer that I got? Is 0.2048. Now we're not done with part B because it says 2 or fewer errors. So that means we're looking for 2 or 1 or 0, because that's what 2 or fewer would mean. So we have to do the probability of 1 and the probability of 0 as well. So the probability of 1 and the probability of 0s, change these to 1s and these to 0s. Okay, so you have to do all 3 of them because you're doing 2 or fewer. You can do this question in Minitab with a cumulative distribution function, everything less than or equal to 2. But we never did Poisson in Minitab, and I tried it. It worked, but it took me a while to figure out how to use it, so it probably isn't worth trying something new there. Probability for 1 is 0.126, and the probability of 0 is 0.0388. So this is 0.126. 1260, that's round to 4 decimal places, and this one is 0.0388. So to get your probability of 2 or fewer, So the random number is less than or equal to 2. You have to add all those up. So the probability for a 2 plus the probability for a 1 plus the probability for a 0, and then we get our answer, 3696. Okay, so that's the answer part B, 0.3696. Part C is an exponential, or otherwise known as inter-arrival time. What is the probability that two consecutive errors will be less than 6 seconds apart? So we don't know how far apart two errors are going to be. They could be minutes apart. They could be a few seconds apart. That's the random number here. How far apart are these two errors going to be? And we want to know the probability that two errors are less than 6 seconds. So this is the exponential, aka inter-arrival time. Probability that the time between them is less than 6 seconds. Well, really 6 over 60, right? So because we have to convert it to minutes. So that's the cumulative distribution function, the capital F for 1/10. So this is 1 minus e to the power of minus, or lambda, sorry, this should be lambda. What's my lambda? My lambda is 13. And then times 1/10. So let's get that all plugged into a calculator. 1 minus e to the power of negative 13 times 1/10. And I am getting 0.7275. So this is 0.7275. All right. Yeah, and that's it. That's our last question. So if there's any questions, email them to me or drop into office hours sometime. The test, I should get that sent out tomorrow, and then you'll have all weekend and turn it in Monday or Tuesday next week or whenever you're done. Okay, stop recording.